Welcome back, friends. Let's continue learning about our basic trig ratios. And we're going to talk about some right triangle trig properties that we just kind of start to memorize because it's faster, right? So first, we're going to look at a equilateral right triangle. We're going to give it a side length 2. We're picking 2 because it's a nice, easy number to deal with. Now, I'm going to show you that we're always going to form the same ratios. And because of similar triangles, we don't have to draw a triangle every time. If we're dealing with some of these really common angle measures, it's going to be much easier for us to, again, just know all of these values. So first thing, what are the angles in an equilateral triangle? 180 degrees divided by 3, all of the angle measures would be equal. Each of these 3 angles is going to measure 60 degrees. All of them are 60 degrees. All right, now I'm going to drop a perfectly straight vertical straight down. And because this is equilateral, it bisects this angle and it also bisects this side. So now let's think about this smaller triangle I've created in here. I'm going to pull that out. So we have a smaller right triangle. Well, we know, as we said, that all 3 of these angles were 60 degrees. So this angle is 60 degrees. When I dropped that vertical, I created a right angle, or 90 degrees. And I also bisected the angle here on the top, which creates this as a 30-degree angle in there. All right, let's think about our sides. What would the sides measure? Well, this long side, which is now the hypotenuse in my right triangle that I extrapolated out, that side is 2. When I dropped this vertical down, it bisected this side. So this base is half of that, or 1. And if I use the Pythagorean theorem to find this missing side, I would say x squared plus 1 squared equals 2 squared, or x squared, 2 squared, take away 1, that's going to be 3. X equals plus minus the square root of 3. We'll find that this vertical side is now root 3. So this represents what we like to call our 30, 60, 90 right triangle. And the ratios in this right triangle are always going to be the same. So even if I scaled this up and made it have a larger size, or a larger length side, I should say, if this was 10, this would be 5, and this would be a 5 root 3, 1 root 3. All right, so memorizing this basic right triangle, you can, or you don't have to, but it's helpful to know it's always going to be this way. So further, we have an isosceles right triangle. The word isosceles means that the 2 legs are equal in length. So it's a right triangle. I have 2 equal length legs. I'm going to call each of those 1. Since this angle is 90 and this is isosceles, these 2 angles would be equal. They must also sum 90. So angle plus 90 is 180, which means angle plus angle is 90. And since these are equal, I can take that 90, divide it in half, and I know that both of these angles in here are 45 degrees. All right, what is the length of my hypotenuse in this isosceles right triangle? By the Pythagorean theorem, I can say 1 squared plus 1 squared, leg squared, plus leg squared equals the hypotenuse squared, or rather 1 squared plus 1 squared, 2 is the hypotenuse squared, where the hypotenuse is plus or minus the square root of 2, or just root 2. So this triangle we have just drawn is my 45-degree right triangle. So two important triangles on this page, and they're always going to be drawn the same way. 30, 60, 90, and a 45-degree isosceles right. Now, if we went through these triangles and we figured out all of my trig ratios, we'd be able to create this table that we can memorize. There's a lot of memorization in trig, and most of it's easier rather than to just per se memorize it to know how it's derived. So we'll just look at our 45 column here. Dealing with 45 as an acute, sine 45 opposite over hypotenuse, that's going to be 1 over root 2, and 1 over root 2 rationalizes to root 2 over 2. I'll get the same thing for cosine of 45, adjacent over hypotenuse, root 2 over 2, and tangent, opposite over adjacent, that's going to give me 1. I can do the same for my 30, 60, 90. I can derive all of these and put them in here. I'm going to write them down for you kind of the way I memorize them, because we're building towards our unit circle logic, and I have the first quadrant, the first quarter of my unit circle memorized, and then I know how to reflect it. So when I think about these, sine, cosine, tangent, 30, 45, 60, I'm going to say 1, 2, 3, 3, 2, 1. Everything is divided by 2. And everything gets a square root over it. I don't know why I changed colors. Let's make those go back. So I'll put a square root over 2, a square root over 3. I can draw my square root over 1, but what's the square root of 1? It's 1, so we don't need it there. So I say 1, 2, 3, 3, 2, 1. I divide everything by 2, and then I add my square roots on the top. So we have a definition that we may not have talked about yet. One thing we know is that tangent theta is the ratio of sine theta over cosine theta. And if you think about that, I can prove that for you real quick. I'm going to start with actually sine theta over cosine theta. Sine theta over cosine theta. Well, sine theta we know by SOHCAHTOA is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. If I reduce this fraction, I get opposite over adjacent. And opposite over adjacent we know means tangent theta. So I don't think I wrote that in either of the two previous videos, but it's something that we know and can use. So tangent is sine over cosine. Sine over cosine, that's 1 over root 3, which rationalizes to root 3 over 3. 1 over root 3 becomes root 3 over 3. Sine over cosine, that's something over itself, so I get 1. And sine over cosine for 60 degrees, I'm going to end up with root 3 over 1, or just root 3. So you can remember this chart. You can remember how to draw those triangles. As long as you know it, it's going to be easy for you to deal with. And you might say, well, Ms. Stein, I don't want to remember it. I'll just draw a different triangle every time. I'm going to show you it's so much faster for you to just remember it from the beginning. All right, so suppose we went to come over here to find 60 degrees by hand. We want to find sine of 60 degrees. Oof, sine of 60 degrees. All right. I don't know anything, right? I don't want to figure this out. This is a lot of work. If we were in class right now, I'd say, hey guys, give me an ugly number. Any ugly number. Not too ugly because we still have to work with it, but not something like 5 or 10. So I don't know, maybe 28. So all three of these sides on this equilateral right triangle are 28. Now, if I drop a vertical, I can again create that 30, 60, 90 right triangle. I've got 28. This base angle is 60. The top angle, which was half of 60, is now 30. The base side is 14. And now we have to find this third missing side here using the Pythagorean theorem. So I'll call that guy x. X squared plus 14 squared equals 28 squared. X squared plus 196 equals 784. I subtract, I've got x squared is 588. Or rather, x is plus or minus the square root of 588. And now I've got to reduce this radical. All right, that's going to be x equals 14 root 3. So, and we can disregard that plus or minus and just say we know it's positive because it's a length. So I've got 14 root 3. All right, a lot of work. I still need to find sine of 60 degrees. Sine, what is it? Okay, here we go. SOHCAHTOA. SOHCAHTOA. Opposite over hypotenuse. So 60 degrees. What is opposite 60? 14 root 3. What is the hypotenuse of this triangle? 28. I wrote theta there. I should have written 60. So we're doing sine of 60 degrees. Now I can reduce this fraction, and I've got that sine of 60 is root 3. 14 divided by 28 gives me a 2 in the denominator. Wow, we had to do a lot of work for that. Wouldn't it have been easier if we just knew that sine of 60 was root 3 over 2? That's what we have in our table up here. So really what I'm trying to emphasize at this point is that these are values that we need to keep stored, okay? Whether you store them by considering this table and drawing this on your paper every time, or if you consider them by drawing those two right triangles every time. Store them in your brain. It's going to make your life a lot easier. And I'm making these videos during COVID when all my classes are online, but I want you to know if you were taking this or if you are in a future class taking this face-to-face, you'll have pop quizzes on this stuff. So I can't do that in an online class, but I can get you in a face-to-face. Really important. I think it's really important that you know these 9 values in the table here. All right, so that's it for this video. We've got one more video in our 6.1 series coming right up.